And then we dive right in now. All right. So most people have a basic understanding of what probability is. Like, for example, if I say you flip a coin, what's the probability of getting ahead? You would say 50%. You could say 1 out of 2. All right. Because why? Probability is a ratio. All right. It's a ratio of the event that you desire to the total number of possible events or outcomes. All right, now what does that mean? In my example, I said, what's the probability of getting ahead? Well, if you flip a coin, there are how many possible outcomes? There are 2 possible outcomes. Of those outcomes, how many of them are heads? 1. That's why I would say the probability of getting ahead would be 1 out of 2. Now, some of you said 50%, and I'm not going to argue with you, but just with probability, it's generally a fraction. All right. So probability at the top of your page is equal to your successful events over the total number of outcomes. And that's how simple it is. Hold on 1 second. I promise I'll answer your question. All right. Sorry, my iPad's acting up a little bit. All right. So we have your probability. All right. Probability is simply defined as your successful events, what you want, your desired outcome, divided by the total number of outcomes. All right. So when I'm looking at this spinner, let's just say I have no idea what the question is, but I'm looking at this spinner. All right. How many different outcomes are there? There are 16. I think there are 16 different. It's okay. It's okay. There are 16 different outcomes. All right. When you spin it, it's going to land on one of those wedges. All right. Or one of those numbers. It can't land on anything but one of those numbers. All right. So there are 16 possible outcomes. Now I could list off a bunch of different questions. Like I could say, what's the probability of getting in the shaded region? I could say, what's the probability of getting an even number? I could say, what's the probability of getting a multiple of 3? There's lots of different questions. You answer the question by looking at the spinner and counting how many successful things that you can count from the question. Then it's going to be over what number?
16.
16, because there are 16 possible outcomes. Really, stay with me now. All right, what, Davis?
So about the coin thing, like if there's 2 outcomes, that means it's 50%.
That's right.
But if you flip a coin, if it's 1 and 2, that doesn't mean that the head is going to get called once and tails is going to get called once, because sometimes you can have both get called once. Like
so listen to right. So probability is just what are the chances that it happens. It's not saying what will happen.
Oh.
You with me on that? That's a very good thought. Listen, probability is based on game theory also, right? And that's how, when you see, for example, let's say your shooting percentage is free throws was an 80%. What does that mean? That means 80% of the time you're going to what? Make it. 20% of the time you're what? You're going to miss. So when you stand at the free throw line, you have what? They're not saying you're going to make it or miss it. They're just saying 80% of the time you'll make it and 20% of the time you'll miss it. All right. Same thing with flipping a coin. Doesn't mean it's always going to be heads or always going to be tails. It just means half the time when you flip the coin, it's going to come up head, and half the time it's going to come up tails. All right. That's exactly what that means. Tell me.
I was gonna say, for that too, can it be, it can't always be right, like, I'm just saying, cause I thought how you did the shooting percentage,
Uh-huh.
like if you're only good at one spot.
No, no, well, and that's why I say there are very good. If you'll notice when you talk about shooting, people, for example, in the NBA, shoot 40% from the 3-point line.
Yeah.
They shoot 100% from the layups. Do you agree with me?
Yeah, like different.
Yeah, there's different percentages, but overall, their shooting percentage might be 50%. All right, so there are different places that you can break them down, but an overall percentage. Is that making sense?
Yeah.
All right, again, I don't want to complicate it too much because it's really not too complicated, but as you get smarter and you understand math more, statistics and probability becomes harder. All right, I personally think it's the hardest subject. All right, but anyway, let's take a look now and let's see if I've taught you anything so far. What's the probability of getting a 10, everybody? 1 out of everybody. That's what I'm talking about. Because you paid attention, it's an easy thing. 1 out of 16. All right. Now let's look at the probability of getting an odd.
One in
Yeah. Now listen, I'm okay. Thank you for all inputting. We're not going to name probability as a percentage. All right, we're not going to name it as a percentage. Although 1/2 is the same as 50%, probability is a fraction. Probability is a fraction. So in this case, I want the probability of being odd. I already like what somebody said. 8 out of 16. There are 8 odds out of 16 possible numbers. Now you would reduce that to 1/2. Now some of you are saying, well, I already knew it was 1/2. Do I really care? No, I don't really care. I'm just simply going strictly by the definition. There are 8 odds and there are 16 numbers. Therefore, the probability of getting an odd when you spin it is 8 out of 16, which reduces to 1/2. So half the time you'll get an odd and half the time you'll get a what? Even. All right, does anybody have any issues with that? All right. So now, it says, what's the probability of getting a number greater than 7? Yeah, some people have a problem with that, right? So if you want, that's why I'm always going to have it on the test. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. A lot of people thought it was what? 8. A lot of people thought it was 8. All right. So what do we say it was now? 9 out of 16. And that's it. All right. Uh-oh. Now this is a good review problem. I need prime numbers. So, but I want to list the prime numbers. What are the prime numbers?
2, 5, 7.
Shh, shh. No one's asking you. She made one mistake. What mistake? Anybody? What? 1 what? 1 is not prime. Everyone thinks 1 is prime. All right, but and this is on a lot of standardized tests. So I'm trying to tell you, make sure you put it in your mouth, in your memory. Listen to what I'm saying, please. The definition of prime is it has 2 factors.
one in itself.
1 in itself.
It only has one because one in itself are just one.
That they have to be different numbers. Is everybody with me on that? You see how? Listen to the definition now. You have to have 2 factors. 1 doesn't have 2 factors, so it's not a prime number. It's also not a composite number. All right, it's also not a composite number. So now let's look at that again. Is 2 prime? Yes. Is 3, 5, 7, 9, 11.
Oh, no, 9's not.
I didn't say it was. Is 11, 13, and 15. No. Now, why did I skip all the evens?
Because those can never take them.
Because they can always divide by what? Yeah, you can always divide by 2. So what's the only even prime number? 2 is the only even. So now we count that. How many do we have? 6. So everybody's going to write down 6 out of 16. And then we'll reduce that to what? Come on, guys. 3/8. All right. Now, again, we're trying to practice. The reason I like this because it overlaps with our what? Fractions. So you have to practice your fractions, preparing for our ERBs. All right. I think it says, what's the probability of spinning a 1 or 2? What's the probability of spinning and let's just go ahead and write it down there. 5, probability of getting a 1 or a 2. And what did you guys tell me it was? I like what you're saying, 2 out of 16, and then that reduces to what? 1/8. Perfect. All right, now please when you take your test, don't just automatically assume you're correct. All right, you should look at it. All right, what's the probability of getting a number less than 5? Yes, I like it. 4 out of 16. And then, of course, we're going to reduce that to 1 out of 4. And now we're going to talk about the probability. Can you guys see the shaded region on yours?
Yeah.
All right, so what is the shaded region? Anybody else get 5 out of 16, right? All right, I told you, very easy. And then if you're not shaded, then you are what? How did you know it was 11 without counting? 5 plus 11 is 16, or 11, or I'm sorry, 16 minus 5 is 11. Is everybody with me on that, right? You're either shaded or you're not shaded. You can't be in between. All right. So that's why if there were 5 shaded, we automatically knew there were 11 unshaded. Is that making sense? All right. So now let's look. All right. So in a bag, you have 6 red, 3 blue, 15 green, and 6 yellow. All right. So you're going to dig into the bag and you're going to calculate some probabilities. So what is probably something important that I would need to know? How many there are. So right off the bat, I just want everybody to add those up for me. And somebody said there are how many? So I would like everybody to put down there a total of 30 marbles. The total is always important for probability. The total is always important for probability. All right. So number 9 says, what's probably getting a blue? Yes. Come on, stay with me. 3 out of 30. And of course, we just reduced that 1/10. All right. These numbers nice and easy. So there's not a whole lot, all right, of trouble. So probability of getting a red, 6 out of 30. And of course, everybody can reduce that right now to what? 1/5. All right, now let's talk about the probability of getting a green. 15 out of 30. And we're reducing to 1/2. All right, I told you guys, very easy. All right, so if you're not yellow, you are what? Everything else, correct? So instead of counting 6 plus 3 plus 15, if you know there are 6 yellow, what could I do quickly? Yeah, you just go 30 minus 6. Everybody agree with that? All right. So you would say there are how many? 24 out of 30, and that reduces down to what? 4 out of 5. Thank you very much. And now, what's the probability that I'm not green? Right. Now, what's the probability that I'm green? I know, but we already did that problem. So it was what? 1/2, right? So if half the time I'm green, that means what? Half the time I'm not green. Is everybody okay with that? All right. Now, what's the probability that I get a black marble? Yeah, are there any?
No.
No, 0. All right. You don't have to put 0 out of 30. You just put 0 down. All right. So what's the probability? Now, look, guys, here's what I'm trying to show you. You can do it a little bit quicker now. Look up. Notice it says probability of blue is number 9, right? What's the probability that I'm blue? 1 out of what? 10. So now what's the probability that I'm not blue? 9 out of 10. Now, some of you guys just sit there. You never ask me. You're having trouble. You're not understanding. You just sit there. Is anybody having trouble with this? Right? I think this is an easy skill. At the beginning, hopefully you were like, well, I'm not 100% sure. But now that it's been explained, it's super easy. All right. So once again, what's the probability of red? I'm asking a question. You got to listen to me. What's the probability of red? 1/5. So if the probability of red is 1/5, the probability of not red is 4/5. I'm happy. Now, what's probably getting a red, blue, green, or a yellow? Why 25 out of 30?
4 of them and 4 of them, 4 times 25 is 100. You already got 1. 100.
Well, how many red, blue, green, or yellows are there?
30.
30, right? Yeah, 30 out of 30. Right. So what does 1 mean? 1 means for sure you're going to get, when you put your hand in, you're going to get a red, blue, green, or a yellow. You have to. Those are the only possibilities. Does everybody agree with that? Just like when they said, what's probably getting a black? If you put your hand in and try to grab a black, is it possible? No, 0 chance. It's not in there. All right, that's what you're supposed to understand. Okay, so now I need someone to help me with this. What does frequency mean?
How many times?
Yeah, so the number 1 has a frequency of what? So how many 1s are in the bag? How many 10s are in the bag? How many hundreds? And how many thousands? Is everybody with me on this, right? So again, what did I tell you the most important thing is? The total. So what did you say? Somebody said there were 50. There are 50 numbers. Is that correct? All right, so if there are 50 numbers, now remember, frequency just is how many of them there are. All right, so let's take a look at number 18. What's the probability of getting a 10?
Oh, wait, no, 16 over 50.
Right, so we're going to say 16 over 50. Hold up a second. 16 over what? And what does that reduce to? 8 over 25. Now, I just noticed you guys, those of you guys who were saying percent, I appreciate it. Do you hear me? I wasn't even reading the directions. So some of you guys were trying to tell me percentages. That's in the directions. All right, we should go back and look at that. All right, but let's just start with number 18. Can anybody tell me what's, without using a calculator, this is what we're practicing mental math. What percentage is 8 out of 25? Tell us.
16 out of 100. 32 out of 100.
Yes, 32%. How did we do that? Yeah, multiply 16 times 2 or multiply 8 times 4. Is everybody with me on that? Come on, guys. You can't go into high school and someone says, what's 8 out of 25? You're like, well, I have no idea. Right? Everybody should be able to look at that and say, okay, I'm out of 100. That's 32 out of 100, which is 0.32. If you did it with 16 out of 50, it's multiplied by 2. All right. So what's the probability of not getting 100? Not getting a 43 out of 50. Now, if you're looking at me going, I don't know what the guy's saying, you got to tell me. Does everybody agree it's 43 out of 50?
Where'd you get the 43?
Because how many hundreds are there? Shh, 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 shh. How many hundreds are there?
7?
And how many numbers were there? So how many are not sevens?
Oh, okay.
You with me? Now, of course, everybody's going to jump on this now and say 43 out of 50 is what percentage?
86.
86%. Come on, join us, please. 86%. All right. Now what I want to hear is what's the probability of getting 1,000? Go ahead. Hold up. Go. I just multiplied by 2 because that's 86 out of 100, right? Yeah, yes. All right. So probability of getting 1,000 we said was what?
45.
Probability of getting 1,000 is what? 5 out of what? 50, which reduces to, which is the same as 10%.
Wait, I did 45.
Yeah, because you minus.
What are you talking about? Come on, guys, don't try to change me. All right, you look at your work before you tell me I'm wrong. All right, probability of getting 1,000. All right, what's the probability that you get an even number? What? Why?
For 22 and 16 together is 30.
Yeah, I want you to tell me the only odd number is what? 1, right? You knew what the answer was. Does that make sense, right? The only odd number is what? 1. 100, 10, 100, and 1,000, and those are all what? Evens. So we would say 22 out of 50, and we're going to reduce that because we're practicing. 22 out of 50 reduces to what? Come on. That's embarrassing. 22 over 50 reduces to what? 11 over 25. And then, of course, you can tell me that that is what percent? 44%. Beautiful. Okay. Now, what was the probability of 1,000? No, come on. Look at your 1/10. So the probability that you're not 1,000 is what? 9/10. Come on, I'm trying to help you get a little better with this. What? You all right with that? All right. And then 9/10, of course, is what percentage? 90%. All right. Now, if you're even, you were what? 11 out of 25, right? So if you're not even, that makes you what? 14 out of what? 14 out of 25. And that's equal to what percentage?
26. No,
What?
56.
56.
Yeah, some of you are using calculators. All right.
Okay.
You're supposed to be doing mental math. All right. Is everybody okay with that? It doesn't matter. It doesn't matter. All right. Now, what? Tell me. Shh. Yes, it's 4. That's right. You're doing good now. You with me on that, right? 4 times. All right. The other way you could have said is 100% minus 44%. All right. Now look, I do want to express it as a percentage because we can practice. All right. So homework is to finish up. Now, don't think those word problems in the back are hard. You got to read them. Is everybody hearing me? All right. Read them. Let's go. Give the rest of this. All right. And again, you should recognize they're all exactly kind of the same. All right. Just different numbers. That's it. All right. So I want everybody to get busy on that. Now, the important ones are 43 through 48. So hustle up, guys. Get that taken care of. Why? The rest of them, everything, every single question is homework. Finish it up. When you walk in the door, I'm just going to collect it after I ask if there's